Yes, class. Am I audible to all of you? Abdul, Leena, Mariam, Shaista. Am I audible?
Yes.
Okay. So yes, in the last class we had stopped at this point where we had found and we had calculated the velocity. Actually, we had derived this entire formula. So this was the value of velocity, which is known as the safe limit. And this specifically, this entire huge formula, this is there when the road is curved as well as it is banked also. It means the road is curved plus there is an inclination. So for that inclination angle is theta, and we use this formula under root rg mu cos theta plus sine theta divided by cos theta minus mu sine theta. So mu is friction, coefficient of friction. Now, one or two points were left to be discussed from here. Bending of cyclist. So, from this topic, no, bending of cyclist, you just have to remember few details. See, suppose the cyclist is at this point. So, downwards, mg will be there. Now, see, what you have to remember, what is the distinguishing point from other questions is that whenever we have normal reaction is always perpendicular to the surface of contact. If our surface was flat, normal reaction was like this, if you remember. And for inclined plane, whenever we had inclined plane, normal reaction, it could have been like this, but no, since it is always perpendicular, it becomes like this. If you take the surface like this, normal reaction becomes like this. So I hope this concept of normal reaction is clear to you, that the angle formed will be 90 degree and it will always be perpendicular to the surface. So when a cyclist is cycling, what happens on a straight road? The cycle is straight. The cycle is kept straight. The tires of the cycle, these are kept straight on a straight road. But as soon as, even you people must have done cycling. So whenever there is a curved road, so what you do, if you keep your body straight as it is, you will fall off. If you do, you have to tilt your body along the curve. If the curve is moving towards the right, it's a rightward curve, you have to curve your body and bend towards the right side. And if it's a left curve, you have to bend towards the left side. So you people have seen also and must have experienced also that if you do not bend your cycle, you are not able to curve it. The turning process becomes difficult, right? You have to bend a little. Not just for simple turns, not for right-left turns, when there's a curved part, circular motion or curved portion. So what you have to keep in mind when you are getting a question from bending of a cyclist, that normal reaction cannot be straight this time, because the cycle's tires have been tilted like this. So normal reaction will also be like this during the turn. This is what you have to keep in mind. Otherwise, rest of the questions, these are similar to what we have studied. All right, so mg is acting downwards. Normal reaction is being taken, not perpendicular directly, but see, this is still perpendicular. The surface of contact this time is this. But here it is, we cannot use this question as it is. No, we cannot use this normal reaction as it is, because this is not helping in any manner. You have to have the forces along the rest of the forces to balance them. So here the angle that we'll take, this will be theta. So again, you will resolve, this becomes n cos theta and this becomes n sine theta. Now you know which force is providing the necessary centripetal force. Yes, Abdul, out of all the forces, n cos theta, n sine theta, mg. I've resolved n also, so n is no more. We have, instead of n, we have n cos theta and n sine theta and mg. Out of these three forces, Abdul, you tell me which is providing centripetal force. Which is providing centripetal force? Khadija?
N sin theta.
Which force?
N
N sine theta, correct. See, n sine theta is providing the necessary centripetal force, right? So n sine theta is equal to mv square by r. Because here this is acting towards the center and along the radius. How to identify this? Abdul, you're present or not in the class? Respond with a yes or no in the chat column if you are unable to mute. Okay, now it's clear, Abdul, to you why n sine theta is equal to frictional force, because this is acting along the radius and towards the center. Okay, good. So yes, this is the case, and n cos theta is balancing mg. So you have n cos theta, which is balancing mg. Now take their ratios. N sine theta is equal to mv square by r divided by n cos theta into mg. Mass will be cancelled. Normal reactions are getting cancelled. And what is sine theta by cos theta? Tan theta. Tan theta is equal to v square by rg. So this is equal to rg tan theta under root rg tan theta. This is the, now this becomes the safe limit for the cyclist to move. Fine. Write it down. This was the last derivation which couldn't be completed in the last class. It's just that one point you have to remember, derivation is very easy. You just have to remember that normal reaction is not straight this time. It is a little bent at a certain angle, because when you are turning, cycle also turns away. When you are moving straight, tire is like this. And when you are bending it, tire is like this. So there's an inclination which is being bent. Write it down. Now, see one small concept that some of you will encounter these types of questions. Motion in a vertical circle. See, what is meant by motion in a vertical circle? This is if you take a string and you tie at the end of the string a bob and you're rotating it. So how does the motion appear? Your hands, which is your hand which is holding the thread, that initial point will be fixed over here at the center. See, this was the bob. So when you will rotate it from the center like this will move like this, then it will move like this, then again it will move like this, and again it will move like this. So this motion, no, which occurs when you are rolling something, which when you are moving something, this is a vertical circle. So here there isn't any difference so much. It's just that if you are seeing a question, the concept will be the same. Just one addition. What we have been studying, downwards mg will act, upwards here upwards mv square by r, this will act, right? And what have we been studying? Mv square by r is equal to mg. This is balancing it. Just one more thing, since this is a string or a thread or a rope, there will be a tension force also. So tension force will also be added with this. Fine, this will be added with this when we're talking about the motion in a circle. If we talk about this point, now look, tension is acting here, mg is acting here at this particular point. So this time tension plus mg will be providing the necessary centripetal force together, mv square by r. So this becomes T minus mv square by r is equal to mg. So this equation and this equation, these two equations are helpful for such questions. That's it, what you have to do. Write it down. And yes, sometimes it happens that you are asked to calculate the velocity. What is the velocity of the body? And one more thing, you remember class, if suppose someone cuts the thread in between, then this will move off tangentially because of the tangential velocity. So this will be moving tangentially. Note it down. We'll start straight away with work energy and power now. This is motion in a vertical circle. Yes, class. Now starting with the next lesson, that is work, energy, and power. So this is a very short lesson. This is not a lengthy lesson like your laws of motion, which has so many concepts and motion in a straight line and all. See, it's just that now from here you will be studying about scalar quantity. Work, energy, power, all these three we'll study separately. Out of all these three, power is a very small topic that will just take half an hour. Work is also a very small topic. The major topic which you have to remember is energy. All right, kinetic energy we have to do in detail, potential energy we have to do in detail, because this is the only lesson which has an elaborate information about energies. Work done is in any ways a very small topic. Power is also very small, so you will be able to manage. And apart from these three, you have a topic collision, which we'll be doing once we are done with power. So again, I'm telling you, this is not a very lengthy lesson. This will not take so much of time. Just pay attention in the class. That will be sufficient. And once revise it after the class. What is meant by work done? Suppose this was a block of mass M. I have applied a force and I have pulled it. Because of pulling, what has happened? The mass has arrived this point. That is certain displacement it has covered. So there was an angle also formed between force and displacement. So what is work done? Work done is the dot product of force and displacement. Dot product of force and displacement. What have we studied in dot product? Magnitude of force, magnitude of displacement into cos theta. Fs cos theta. This is the condition where your force is constant. If there is a variable force, that I'll tell you separately. And class, scalar, work done is scalar, energies are scalar, power is also a scalar quantity. That's why this lesson is short. The tough vector additions and signs and all the directions have been deleted because it's a scalar quantity. You just have to add or subtract. And what is the SI unit of work done? Work done and energy both have the same SI unit, that is joules. And CGS unit is erg. So we write this as erg, we write this as joule. So you must have heard somewhere 5 joules of work is being done, 3 millijoules is being done, 6 millijoules is done, 3 microjoules, like this. You must have heard. So this is what is meant by it. We'll start with a very basic question. Just let me tell you how to use the formula. Force 10 Newton acts on a body and it gets displaced by 5 meters. Force is 60 degrees to the displacement, calculate work done. So F dot S we will take, that is Fs cos theta. So what is work done equal to? Force is 10, displacement is 5. This is cos 60 degree. That is 10 into 5 into half. This becomes 5. 5 multiplied to 5 becomes 25 joules. Like this, a very basic question. But see, this involves your knowledge of dot product. If you're very familiar with dot product, you will find this portion of work done very easy at least. Write it down. One more question based on dot product we see. Though these types of questions we have already practiced on dot product. But since most of you were not there, that's why I'll do it again. See, in this question, force is given to you in the form of Cartesian. It's given in Cartesian form. So see, A point is 3, 2, 1. B point is 2, 1, 1. So initial point is there, I cap, J cap, K cap. This is also I cap, J cap, and K cap. So force is there. So this is the initial point, that is RA, which is 3 I cap plus 2 J cap plus K cap. This you will write it in this form. This is no X, Y, and Z. So that's why you will write it in this form. Then only you'll be able to solve the question. RB is 2 I cap plus 1 J cap means J cap plus 1 K cap means K cap. Now, when we say displacement, if this is the initial point, this is the final point. So how do we calculate the displacement? RA minus RB. Sorry, RB minus RA. Final minus initial. So final is 2 I cap plus J cap plus K cap minus, all the signs will change, minus 3 I cap minus 2 J cap minus K cap. So what are we left with? This is now the net displacement. 2 I cap minus 3. This becomes minus I cap. J cap minus 2 J cap minus J cap. K cap minus K cap will be cancelled. This is the net displacement. What is the force? 2 I cap plus 3 J cap plus 5 K cap. This is in meters, this is in Newton. So when we are taking their dot product, so all the coefficients, like coefficients, will get multiplied. So for work done, you will have F dot S. Force is 2 I cap plus 3 J cap plus 5 K cap dot. Displacement is minus I cap minus J cap. So this means 2 multiplied to minus 1, because coefficient here is 2. And what is the coefficient of I cap here? Minus 1. Plus what is the coefficient of J cap here? 3. Coefficient of J cap here is minus 1. So into minus 1 plus. Coefficient of K cap here is 5. Coefficient of K cap here is nothing. So 0. Finally, we have minus 2, minus 3. So work done is minus 5. This is how you have to solve the questions given in Cartesian form. For polar form, this formula, Cartesian form, this. Write it down. See, this force is F is equal to 3x square plus 2x. Now see, if I put the value of x as 0, what would be the value of force? Force would be 0. Yes, if I put this x as 0, force will be 0. If I put the value of x as 1, so force will be 5. Can you see, if I am changing the value of x, the force is also getting changed, right? So it means this is not a constant force. Earlier, if you see any question, this here also 2i cap plus 3j cap plus 5k cap, this force is fixed. Here also the value of force was 10 Newton. You put the displacement as 5 meters, you put the displacement as 10 meters. No value of force will change. This value of force will remain as it is, as 10 Newtons. But see, so you cannot use the formula which I told you, Fs cos theta. So which formula you have to use when you are having a variable force? You will integrate it from initial displacement to the final displacement. This is when the force is variable. So know the usages of these formula. So now what is the question? Question has given the value of force as 3x square plus 2x dx and to integrate it from 0 to 2. So this becomes 3x square dx plus 2x dx and we have to integrate them from 0 to 2 both. Now all those who are not familiar with integration, please revise the concepts of integration. When you have x to the power n, so this becomes n plus 1 and now whatever power has been obtained gets in the denominator. So what will this become? 3 is already a constant. X to the power 2, see plus 1, that becomes 3. And whatever is the power that gets divided. So from 0 to 2. Plus this becomes 2x to the power 1. So 2 is constant. Now x to the power 1 means this. So plus 1 we'll do, that makes it x square divided by 2. That is from 0 to 2. So 3 will be cancelled, 2 will be cancelled. Now see, we put the upper limit first minus lower limit. So in place of x, whatever is the upper limit, put it. That becomes 2 cube minus 0 cube plus upper limit 2 square minus lower limit. So what are we left with now? This is 8 minus 0 plus this is 4 minus 0. So the answer is 8 plus 4. Final value of work done is 12 joules. This is how you have to solve if you are given a variable work done. Write it down. T class, the last portion from work done, no? Work done is almost over. Work done just had those portions of the formula F dot S. Now graphical questions can also come, as I think I had mentioned this to Abdul and Khadija on that day. Other students weren't there. Let us just properly discuss graph. See, remember this. This is very important. When you are when two quantities are getting divided, the third quantity will be given by the slope, that is tan theta. This means suppose velocity is equal to distance by time. So distance divided by time. So I'll calculate tan theta, that is slope. But if two quantities are getting multiplied, then I'll calculate area. For example, displacement is equal to velocity into time. So if velocity versus time graph is there, I'll not calculate tan theta and find out distance. In that case, distance will be given by the area under the graph. But when velocity was asked, displacement versus time graph was given, then I would have taken the slope. So here also force is getting multiplied. So which case? Second case, that is you will take the area under the graph. So positive for the all the area above the axis, displacement axis, and negative you will consider all the area which is below. Now if it's a triangle, half base into height you will use. If it's a square, side into side you will use. If it's a rectangle, length into breadth you will use. Like this, if it's a semicircle, sometimes the forms in our questions like this, cosine or sine graph. So you will use pi r square by 2. So proper area of the figure which is being formed. Trapezius is there, half into height plus sum of base, sum of the opposite side you will consider. So area above the displacement axis is positive, area below the displacement axis is negative. Do one thing, write it down, then I'll discuss this question. So in the next class, we'll straight away start with energy. Write it down. C class. Like this, you have a question, force versus displacement is given. Now see, all the parameters are marked. This is 0, the origin. This is the origin of the graph. This is the displacement axis, so +3 above, -2 below. This is 2, this is 4. Now you have to find out the total work done. So force into displacement. Whenever we have multiplication, we'll take the area. Had this been a question, and the formula of work done would have been force divided by displacement. So then two quantities are getting multiplied, then you will take the slope. You must have calculated tan theta. Here slope will be 0, here slope will be something half or something. But it is getting multiplied, so we are taking the entire area. Like velocity is equal to distance divided by time. If displacement versus time graph is given, you will calculate tan theta, that is the slope, to find out velocity. But if velocity versus time is given and you have to find out displacement, so displacement will be velocity into time. So if this is the graph, you will calculate this entire area. This should be clear to you, because this is not just a concept for work, energy, and power. This is a concept throughout your physics, which will be staying with you. So what is the work done? Work done will be area of the rectangle plus the area of the triangle. So if this is 3, it means this is 3. So this is 3. And this is 2. So this is 2. Though this is not drawn properly, 3 should be greater, 2 should have been lesser. So this becomes area of a rectangle is length into breadth, 3 plus 2, plus area of triangle. Half base, base is this. This is 2, this is 4. So this part left is 2. So half base into height. What is the height? Height is this. So this is -2. So into -2. 2 will be cancelled. This is 6 minus 2, which is 4. So if this is minus, you will write it as minus, because these are scalar quantities. We have to write them as it is. First, tell me that this is all about work done. Now we'll be discussing energy, and in energy, whatever concepts of work done will come, that we'll see. First, tell me, all of you, in the chat column, reply with a yes or no. Till here, is this clear? The entire concept of work done? Okay, Abdul, Khadija, other students, Lina, clear. Nuha, Afshin, you have understood, Mariam?
Yes, ma'am.
Okay, Nuha? Present, Nuha? All right, write this page down, class. Now we'll start with energy in the next class. As I've already told you, this is not a very big lesson, but some concepts are there. Kinetic energy and potential energy, at least we'll discuss in detail. That will only take time. Fine, if you people have completed, you all can start leaving. Those who have completed, we'll start with energy in the next class. Please attempt your after class assessment. Thank you so much, class.